Hello everybody, my name is Vahid Garusi and I'm going to present today our progress with a model-based testing project in the context of a European project called TESTOMAT and in partnership with a large software testing company in Turkey called SUT, which develops a tool called Testinium, and you can see the logos of the company essentially in the on top of the page. The funding for this project we have received from ITIA3 consortium and also TÜBITAK funding agency in Turkey. So what I would like to mention today is really essentially a review of the project and the context of the project. As you can see here, we have the web page for TESTOMAT project, which is a large European-wide project consisting of 34 partners and running for about 3 years and with a large, essentially, grant budget. You can see all the details about this TESTOMAT project in this website. The partnership that we are running now is with a company called Testinium and SUT in Turkey, in Istanbul, Turkey. You can see the website of the company here and also the nice photo of the team members of the company. So as I mentioned, this is a model-based testing initiative and activity. I'm going to mention you the test tool that we have used so far, and also the system under test. The system under test is actually a test tool itself called Testinium. It's actually a continuous test automation for web and mobile application and for test management of such activities. That one can define test activities, and the tool will connect to Selenium, Appium, and a few other test automation frameworks to run and report test cases and report the results. If you would like to see more details about what Testinium can offer, again, you can see the website here. And also on Vimeo, there is a demo video for Testinium itself, which can be seen here.
Resulting in high operating costs and low profitability. So many types of mobile devices and mobile operating systems. So many types of desktop operating systems, browser and browser version combinations.
So essentially, I'm going to now also, in terms of system under test, we are using a tool called Graph Walker, which essentially lets you to define your model-based testing environment and the test models using state chart formalism. You can define nodes and vertices. I'm going to show you a few examples of that. So it's a very nice tool, and we had the choice to look at several model-based test tools, and this was by far the best one that we could use. So for example, in terms of what system under test, our system under test, as I mentioned, is Testinium, and the first page is the login page. After you log in, you will come to a page so-called dashboard that you will see the status of your test suites that have run, etc. You can see different projects, you can define different projects, all scenarios, and all test scenarios. So a project can have many test scenarios, and then you can also have many test suites and also test reports. So this test tool, essentially, Graph Walker has a web application interface. So essentially what you have here, I'll try to now essentially make the page like this so we can see both entities. So essentially, an example that I would like to show you is the login page. That's the login page of the system under test. And this is the model that we have defined and developed for it by applying the best practices in model-based testing. For example, I need to check the very start of the model-based testing is really where we ask the tool to go to the login page, and we need to verify that we are in the login page. So to verify that we are in the login page, we need to write the Selenium test, some Selenium Java code behind it. And from that page, I can either go and I need to run different test cases. One of them is verify invalid login if I provide an empty username password, if I provide an invalid password. So it has to verify all of them. This part is for essentially if I forget my password, so verify in forgot password page. So as you can see, I go there. If I run the event, click forgot password button, I'm verifying that I'm there. Then I will test the case that I will input a registered email address. So it should send me an email. If an email is not registered, if you put an invalid email for forgot password, it should say that you don't have an account. So and afterwards it should come back to login page as well. So to define that, essentially we defined, as you can see here, essentially several test Java Selenium methods. For example, for verify in login page, I need to verify that the URL is this one. So the system has come to this URL. I have to check that the username login box is visible, the password box is visible, and all those other buttons are visible. These are some assertions that are taking place. So altogether, we developed a lot of test models. Actually, in total, we developed, these are some size measures that we have measured. As you can see, we developed 18 test models. So this is the login one. There is also we create. So each tab here is a test model essentially. Altogether, we can zoom out and in here. They had 177 nodes and vertices, and 260 edges. So it's quite a lot. We also measured the amount of test scripts that we wrote, and that is here. Altogether, all this Selenium code that we wrote together were about 6,737 line of code, and this is a kind of simple line of code tool that we have used to measure them. So now we're going to run the test suites and see how they run. As you can see, the system is running the model-based test tool. Essentially, is running our test models, and in a quite, I would say, robust manner. So we have done a lot of work to ensure that the models are designed properly. In the actual issue of test case design, we use the established literature on that essentially to make sure that all the important elements on each UI page are verified, and we are essentially covering all the elements and asserting them as well. As you can see, because system under test, is a commercial application. Well, it's a very high quality, so we are not going to see any test failures in this test run. But of course, this will help in regression testing and also for other projects that we are now applying this model-based testing approach. So I should also mention that all the models that you see in this screen, the test models for the Testinium application, this larger scale test model, and all the supporting Selenium code are available on a GitHub repository that you can find below this video. All the folks that are interested to see how we have done this model-based testing can download them and also run them using the open source GraphWalker tool. So I would like to pause the execution of model-based test scenario here, but it actually takes several hours. We had done a video capture of that for about 25 minutes, and I showed you part of that today. I also would like to acknowledge the great efforts of test engineers in SUT Corporation in Turkey, and my two colleagues Alper Burak Keleş and Yunus Balaman, which did a great job in collaborating with me and all the team to develop and essentially deploy this model-based testing approach. Our activities have provided a lot of benefits to the company, and we are in the process of writing a few publications out of this as well. Goodbye, everyone.